Hi, I'm Nancy Hylton, and our journey with dynamic orthotics really began in about 1971 with some modifications to shoes, and that changed things in the rest of the body in a positive way. Everything that was available orthotically at the time really posed a lot of restriction. So the children who were really active, they wouldn't wear them. There was exploration with a system that helped us to be more precise with the foot. It was called a footboard. And I made some modifications to that and felt that I could get more precise control and the casting could go faster when we did that. So at the same time, in the 80s that this was happening, we were exploring other ways to help support children. And we had a system of custom contoured flexible foam that we used for seating inserts to help them to be able to be stable and to be able to be in midline and to be able to be comfortable in the seats. Also, began to explore with compression, with elastic ace wraps. And out of that, we began to explore the use of neoprene compression. Cheryl Allen arrived with her foster to adopt son. He had a spastic diplegia type involvement. She had a second son who had much more severe problems. And we discovered later that he had huge sensory problems. It was a significant motor problem early on, but later we recognized that there was a piece of that had to do with him really not knowing where his body was. With Cheryl's creativity as a seamstress and my kind of thinking, how can we make this work better? Where we're playing with all different kinds of sensory information that we later realized all fed into somatosensory system. There's something about stability, there's something about pressure, there's something obviously about giving input, and it's an orthosis. So we coined this term, stabilizing pressure input orthosis, and Cheryl was doing this exploration with her two boys, and I asked her, do you think you could make a vest with probably double layer, I said, because it's got to be a little bit firmer, a lycra to the front that we could connect to a back panel. She said, well, yeah, I think I can. What happened then was we received those vests, and to our amazement, actually they worked as well as the neoprene vest, and they obviously transmitted body heat much easier and were much more comfortable. And the parents began to say this actually works better than the neoprene, and the child is obviously much more comfortable. And at the same time, there was more and more information coming to us about the nature of balance, how it was organized in the system, and even research about how that was organized as a wave of activation from the base of support. And so this made a different understanding of why the dynamic AFOs were so effective in that way. So this was all kind of coming together. We thought they were separate systems, and then all of a sudden we began to realize that the same underlying foundation principles from neurophysiology and biomechanics were operational in all of these different areas of foam and compression and dynamic AFOs and even, in fact, vibration. Then we began to recognize this connection between this base of support activation that comes up through the whole body, and also then how sensory information given through deep pressure can actually secondarily change the proprioception, the ability to utilize the muscles and grade the muscles in a different way, and that becomes a kind of cyclic improvement for the person because they have a better sense of where the body is. Therefore, not only does the information come from under the foot, but it's coming from the activation of the whole body, and that gives them a more possibility to adapt their movement, to find their balance, to find their middle, and to find especially core activation. I think we've also been on a journey with understanding the nature of spasticity and recognizing that there isn't such a clear division between spasm, spasticity, tension, hypertonus. All of these terms sometimes get a little bit muddy, and they have to do with the state of activation of muscle tissue. And so we began to realize that in fact this tension and spasticity was really hypertonus of different kinds, was really a compensatory phenomenon. Another piece of the science that came together had to do with this interconnection between biomechanical mechanisms and neural postural control, and how both of those systems are organized around balance or mid positions of motion. If you enable the biomechanical system to be more aligned in a more neutral orientation with the possibility of moving into and out of that alignment, that's critical, you're going to change postural control. And it's because the system is so flexible that, in fact, you see that activation. If you put something hard on, the person will just hang in it. But they don't hang in something that's very flexible. They simply feel the compacting of that system. That, in fact, that sensory information reminds them to start to activate the muscles groups themselves. What we discovered was bioorthotics worked quite nicely to help certain populations of children with fluctuating tone, with spasticity, with a combination of spasticity and underlying instability, with spasms and dystonia. In all of those areas, you see more of the possibility to activate and be able to adapt the movement more easily. I'm convinced very flexible TLSO that actually becomes like an exoskeleton next to the body, that it really enables motor learning in a way that can't be accomplished in other ways. And it allows a therapist to really press the limits of the person's abilities much more than they would if they didn't have this tool to work with. And you see that in sitting, you see that in laying and rolling, you see that in kneeling, you see that in standing, you see that in walking and running and jumping. All of these areas have to do with needing to have a predictable trunk activation and a predictable awareness of where the center of your body is. It's a long-lasting system, and it's really a system that's very foundational for our balance and movement control. And so it gives them also, because of that, the ability to focus more easily on what's going on around them, because they don't have to think so much about their bodies and where their body is in space. It can be, for some of those children, quite dramatic change, almost immediate, or it can be something that you see over a course of days. The other thing that the compression does for all of these children is that it changes the effort they need to breathe. It changes the mechanics of respiration. It stabilizes the diaphragm. It provides the abdominal compression that's necessary so that the diaphragm doesn't have to work so hard, and that what you see is the numbers of respirations per minute will reduce as the respiration becomes more efficient. The standard TLSO functions very nicely for mild to moderate hypotonia, and sometimes in very small children for severe hypotonia. What you're after is cylindrical compression to really help them activate in a more erect posture and not slump into lumbar flexion. If you need more support, or say a child is more active but ends up with either a very strong lordosis or has difficulty with stabilizing with rotation when they move quicker and quicker, what we found is that the X panel can be very helpful for those children. We began to explore with the idea of how could we give better stability and still allow physiologic rotational motion to occur. I designed this X panel design to accomplish that. Finally, the most support with the TLSO that you can get is to form a thermoplastic back. It's a low temperature thermoplast. We found that with children who have quite severe curves, they tolerate that much better than they would tolerate a standard TLSO. So in some cases, they are wearing that all the time, or they are wearing that in the daytime in the wheelchair because it allows for better sitting tolerance. And you can actually get quite a lot of curve correction with the dynamic portion of the curve, and you can hold it quite well. These orthoses were designed, like all of the dynamic orthotics, to take the effect that we got with manual therapy and offer it to the children into their daily lives, into their activities, to make their lives more free. And that's why I'm so excited for the possibility for this system to be shared as widely and as greatly, and that knowledge about this system to be shared to anyone. And I'm excited because it is families that have been the collaborators all through the process of designing and continue to be collaborators and helpers in making little slight changes within the system that allows their lives to be easier.